Determine whether the following lines intersect at one point. Do it algebraically. Now I'm telling you specifically that you need to do this algebraically. If you did it graphically, what would be the problem? The problem would be, like we showed in the last video, when you graph it, it's not very accurate. Can you tell if a point intersects, if there's an intersection point that's at, let's say, 1.9, 1.95, 2, 1.89, any of those numbers, really, you can't tell what's going on exactly if they are intersecting at one point. What happens is students get into the idea, they say, well, that's close enough, and so it must intersect at this one point. Instead of doing that, we need to figure out a way to do this algebraically. Now, what did we do in our last problem? We solved a system of 2 equations with 2 variables. Now we have 3 equations. How do we go about doing this? There are multiple ways that are possible. Remember that last problem, we not only solved the problem, we checked it. So hit pause, try to think about how you can do this. Alright. What we can do is take 2 of these equations, solve it, find the answer, and plug it into the third one. And if it works in the third one, then it works in all of them. Which 2 equations? We can pick any 2 equations we want. The most convenient ones would be these 2. If we say our 3x plus 2y equals 4, 5x minus 2y equals 0, add them together, the y's go away, equals 4, so x equals 4 over 8, which is 1/2. Plug it into one of the 2 equations. We'll take the second one at this point. 5 times 1/2 minus 2y equals 0. So we have 5/2. Let's move that 5/2 to the other side. So we'll have negative 2y equals negative 5/2. Now you have to be careful dividing fractions. Dividing a fraction by a whole number causes a lot of confusions for students, and people want to take out their calculators. Instead of doing that, the better way to do it would just be multiply by the reciprocal. So we're going to multiply both sides by negative 1/2, and we'll get y equals, a negative times a negative is positive, 5 times 1 is 5 over 4. So we have this point that the first 2 lines intersect at 1/2, 5/4. Let's plug it into the last equation and see, does it work? We have negative 2 plus 25 over 4 equals 5. So does this work? Without doing the calculation, is it possible that these 2 things can add up to give us 5? No, because you can't add a whole number and a fraction and still get a whole number. Actually, this would be an integer and a fraction and still get a whole number or an integer. The integers are the positive and negatives, and the whole numbers are just the positives. Alright, so this does not work. And so do they intersect? No, they do not intersect at one point. Next problem. Graph y equals 3 and x equals negative 2. What are their slopes? Well, let's start with y equals 3. Give me a point that's on that line. How about 0, 3? So we can go up here. Let's label our scale. Now, I didn't make a particularly big one here. This looks like it's just 4 all the way around. Negative 4. And that's fine. 0, negative 3. Give me another point that has a y value of negative 3. We could say 1, 3. How about 3, 3? Negative 2, 3. Now, typically what happens when we get to there, students want to say, oh, I don't want to think about the next one because I know this one. And given the format of the other one, I don't even want to think about it. Well, let's go through all of it anyways on this, and so hopefully you have something to fall back on. We have x equals -2, so one thing we could write is -2 comma 0. We have -2 comma 0. Give me another one. -2 comma 1, -2 comma 2, -2 comma -2. So we have x equals -2. Now what are their slopes? Remember, the slope is the rise over the run, or the change in the vertical over the change in the horizontal. So we have a slope here. If I looked at these 2 points, how much do they change in the vertical? They don't. They have the exact same y values. So there's a 0 over, now we could say it's 1, 2, 3. It really doesn't matter. So we have a slope of 0. Remember back in the day when you were studying slope, slope is also the study of the incline. And there is none. It's a flat. There isn't. You don't need any extra effort to go across, walk across on a flat surface. When we look at this one, we have a slope, and we can use the letter m. The change in the vertical this time, we can say it's 1 over the change in the horizontal, say 0, because it's not changing. It has the same x values. And this is undefined. Now, one way that some people use to remember this is if you were thinking about climbing or walking on this, and you tried to walk up a cliff, you could say, "Oh no," as you're falling down. And this has no slope. It is undefined. Whereas the horizontal line is not a problem. It has a slope of 0. This also will fit in the y equals mx plus b because it's y equals 0 times x plus 3. The third one, plot points. So let's mark our scale. Now I've set this one up to make it a little bit easier here. I think I have 10 all the way around. You can see the little bit darker lines. Now we have 2, 0. 2 is our x. And then we have 4 comma -6. Let me mark this as A, B, 9 comma 1, C, and then 7 comma 7, which is our D. Let's connect the dots for our quadrilateral. That's the easy part. Now it says show that BD, segment BD and AC bisect each other. What kind of quadrilateral is ABCD? Now the first part of this is easy. We can work on this, relatively speaking. The second part's going to take us some work. How do we show that two things bisect? What does that mean to bisect? This means cut into two equal parts. Well, what point would be right there that they meet at if they bisect it? That would be the midpoint, or that middle point that we talked about earlier. That's the average. So what we need to do is find the midpoint of these segments, AC, and then we'll find the midpoint of BD. So the midpoint of AC, we have A, we could also look up here, we'll go 2 plus 9 divided by 2. Remember, it's that average of them. It's that middle point, the one that's right in the middle. And then the y values would be 0 plus 1 over 2. So we'll have 11 over 2 and 1/2. And if you want, you can write it as 5 1/2 comma 1/2. You don't have to. And then the midpoint of BD, we'll have 4 plus 7 over 2. And then negative 6 plus 7 over 2. And it's your choice how you want to write it. Again, I'll just write it as 11 halves comma 1 half. So when we do this, that point there is 5.5 comma 1 half. Now, what kind of quadrilateral is this? We have to remember our geometry. If two diagonals bisect each other, that means we're guaranteed what is true. Think about that. Two diagonals bisect each other. We're guaranteed the diagonals bisect each other. That means we're talking about a parallelogram. So we're guaranteed this thing is a parallelogram. But what kind of parallelogram? It could be a square, a rectangle, a rhombus. What we need to do is show each one of those to see, either show that it either is or is not those. And you can't just look and say, yeah, that's not a square. How do we show these things? Well, one way to do it is to calculate the length of these two. How are we going to calculate the length of that? If we just write the letter AD, the letters AD, that means we're talking about the length. This is how far over from A to D. We're going from 2 to 7, so that's 5. So we're going to go 5 squared, and it's 7 up, plus 7 squared, square root of. So we have 49 plus 25. 49 is basically 50 plus 25 is 75, so this would be 74. 74 is 2 times 37, and 37 is a prime number, so you cannot simplify that. Let's look at AB. Same thing for the length. We're starting at 0. We're going to go down to 6. And then the change in the x values is 2. So we have 2 squared plus 6 squared, which is the square root of 40, which is 4 times 10. I'll write it out here just to refresh your memory. So it's 2 root 10. So we're guaranteed this is not a square nor a rhombus, since those sides are not congruent. How can you guarantee that it's not a rectangle? A rectangle means we have to have right angles there. Can you show that two angles are right angles? Remember the slope, and we're going to talk about this in just a second as well. What can you say about the slopes of those lines? They are going to be opposite and reciprocal. So the slope, we can write M. That's why I didn't write M for midpoint. M of AD. Now we already figured out that we had a horizontal change of 5 and a vertical of 7. So that's 7 over 5. And the slope of AB would be negative 6 over 2, or negative 3. So since they're not opposite and reciprocal, these two lines are not perpendicular. So what is? It's a parallelogram. ABCD is a parallelogram.